Hey folks, Mrs. White here. Today we are going to be reviewing Chapter 5. Can you believe it? We are done a whole chapter of remote learning, right? Because you folks all joined me at the beginning of Chapter 5. We worked our way through and now we're going to do some review and take our Chapter 5 test whenever you are ready between now and next Wednesday. Okay? So, and I'll talk about it when we get to homework a little bit more. So let's start off by just talking about the general topics that you're going to see on the test. It is going to be less than 20 questions. I started putting it together, have a couple things to fine tune on it, but we're looking at probably having 8 multiple choice questions and then 5 ones where you have to show work. I do and will give partial credit on those multiple choice ones, but I do want to make it really clear to you folks that in order to get all 5 points for the last 5 problems, you have to show all work. So, items you will see: adding, subtracting, multiplying, and dividing using that function notation. Okay, so we'll review and look at that. I know that's been a long time since we talked about it, right? That was right, actually before April vacation, so we'll make sure to revisit that. You're also going to see composition of functions. That's where you take one function and plug it into the other one. And that we also covered before April break, but did review it a bit afterwards. So hopefully you're okay-ish on that. If not, then we have a whole review assignment here. Next, you're going to see inverse functions. I'm not going to include inverses of any powers greater than 1. So it's only going to be inverses of lines, and you'll see what I mean when we look at the review. You are going to have a couple graphing square root problems. So that's going to be on the docket for sure. And then you're going to have a handful of solving radical equation problems, okay? And making sure that you plug them in and check and make sure they aren't extraneous, right? We want to make sure that they work. And if they are extraneous, you can either write extraneous or no solution. So your homework tonight is not really a required homework. The homework is for you to review as needed. So if you watch this video and you feel great, then you can have your parent email me tonight and I'm happy to send them the test and you can take it tomorrow. Okay. You can work on the entire review that I presented you with folks with and we'll look at together. You can do just the sections you need to. I am not going to collect the review from you and I'm not offering anything in exchange for it. So work on the review as needed. I did attach the key. I had to do it as 2 separate documents, but it does have at least one problem from each section worked out and all of the correct answers on it also. So feel free to check that out. Please check that out. And then again, whenever you're ready, between now and next Wednesday, which is the 20th, have a parent email me and you got to work on that test. Okay, so again, it's going to be probably about 13, 14 questions. So it's a little bit shorter than a normal test in Algebra 2, but it's so that you can hopefully finish it in a reasonable amount of time. Okay, so let's hop into going over these topics. So the first topic, like I said, was adding, subtracting, multiplying, and dividing functions. So operations with functions. So you're going to see problems that look like this: f plus g of x, f times g of x, f minus g of x, f divided by g of x. This is the type of problem that I'm referring to. So in these, they give you a function that they want you to use for f of x, and they give you a function they want you to use for g of x, and they want you to actually go through and do whatever calculation. So let's actually, we'll just talk through adding and we'll talk through subtracting. And maybe we'll do number 11 and do number 12. I do have all 4 of these worked out step by step on your note-taking guide or on the key to the review, is what I meant to say. So we're not going to go over these, but we'll talk about these. So when we take function f right here, and we're going to add to it function g. Remember, we don't use these little labels. We're just taking 2x plus 9, and we're going to add to it x squared plus 2x plus 1, which means all we're going to do is combine like terms. And I can actually do this with mental math, right? I can take and combine like terms between these two. X squared, there's no other x squared, so it's going to just stay x squared. I have a plus 2x and a plus 2x, so that's going to become a plus 4x. And then I have a positive 9 and a positive 1, and together they're a positive 10. Because remember, we're adding them, right? And when we add 2 polynomials, we just combine like terms. When we're subtracting, however, you have to remember to distribute the negative. So this would be our first one, 2x plus 9. Then we're going to minus each of these pieces, which means that each of these are going to change their sign. Now, they didn't all just become negative because we're minusing. I just did the opposite sign. For example, if this was a -1 and I distributed a negative to it, it would have become a plus, okay? So now I have no x squareds to combine here, so I'm going to be left with a negative x squared. Then I have 2x minus 2x, which is no x's. I have a positive 9 and a minus 1, which gives me a minus 8. Oh, just kidding, positive 8, right? Positive 9 minus 1 is positive 8. And there's my answer for the subtraction. Now the multiplying takes a little bit more time. When I do f times g of x, I'm going to start off by writing my f function. So I'm going to do it over here in orange, 2x plus 9. And I'm going to times it by, because that's what the closed dot here means, my g of x function. And my g of x function is x squared plus 2x plus 1. And I know you might get confused a little bit because I had written over it in pink before. Let's just erase that off. So to do multiplication, I first notice this is a binomial and this is a trinomial. So I can't just multiply like terms. You actually have to do like crazy distributive property. So I'm going to send this 2x to all three of these. Then I'm going to send the 9 to all three of them, get 6 pieces, and then combine like terms. So I'm going to go through this a little quickly because it should be just a review. 2x times x squared is going to be 2, x to the third. 2x times 2x should be positive 4x. And 2x times a positive 1 is a positive 2x. Now I'll take that 9 and distribute it through also. So 9 times x squared is going to be positive 9x squared. Oops, here when I did 2x times 2x, I should have gotten 4x squared. Sorry about that. Yeah, so 9 times x squared, 9x squared. 9 times 2x should be a positive 18x, and 9 times 1 should be just a plus 9. Now I'm going to go through and I'm going to combine like terms. The only thing I have that's a third power is here, so I'm going to have 2x to the third. Then I have a squared here and a squared here. I have a positive 4 and a positive 9, so together I have positive 13x squared. Then I have a positive 2x and a positive 18x, which is positive 20x, and then plus 9. Okay, and then there's no combining like terms here. At this point, I am finished. Okay, that's it. That's the answer to f times g of x. I take my f function and I times it by my g function. Now, these division ones, I know you want to do long division or synthetic division, or maybe you don't want to do any divisions, but that's what you would do here. That's what this little symbol means. Here, they really just want you to set it up as a ratio. So I'm going to take my f function, 2x plus 9, and I'm going to put it over this trinomial here, x squared plus 2x plus 1. And I should, let's see, this is never going to be a factor of this because its leading coefficient is 2 and this one's 1. So it's actually never going to divide nicely. And so I'm just going to leave it as is right now. Okay, and that's going to be that. So yeah, adding, subtracting, multiplying, and dividing. I'm going to leave these for you. Again, they are in the key, but I would encourage you not to look at the key yet, but try those 4 on your own as a review. In the next section, we're going to be looking at compositions of functions, and this is where we have this funky symbol, that open dot, which means kind of the word of, right? So we're going to say f of g of x, or g of f of x, and it just means take your f of x and plug it into the g function. Or in this case, take your g of x function and plug it into the f. So I went over 17 and 19 step by step. So maybe for a review right now, we'll just do 18. So we'll start off by doing f of g of x. And again, that's telling me take my g of x and plug it into the f function. So I'm going to take my g of x and plug it in to my f function where the x is. Ooh, this is a gnarly problem. I'm glad we're doing this one together. So instead of x squared, I'm going to put 7 minus x squared. And then I still have to put my plus 1 for my f function. Now, you may want to just send the squared here and here, but I want to remind you this is a binomial, so I'm actually doing x minus 7 times x minus 7, which means I need to double distribute. Or if you had Mrs. Boyce or Mr. Andreessen, they might have said FOIL. So I'm going to send my x here and here, so I'll end up with an x squared minus 7x. Then I send my negative 7 here and here, so I have another negative 7x, and then negative times a negative is a positive, and 7 times 7 is 49. And I'm going to bring down my plus 1. Ooh, plus 1. Now I'm just going to combine like terms. X squared minus 14x. 49 and 1 is a plus 50. And again, I got the 14 from the negative 7 and the negative 7 put together. There's no more simplifying here, so boom. That is f of g of x squared minus 14x plus 50. Now I'm not done. The second half of the directions is to do the other one here. So I'm going to do g of f of x, which is telling me to take my f of x function and plug it into my g function, right? Okay, so my f of x is this, x squared plus 1. That's gnarly, sorry. It's x squared plus 1. I'm going to plug it into my g function. So instead of having x minus 7, I'm going to have x squared plus 1 minus 7. Now this one's super easy, right? There's no anything to multiply. There's no power here. So all I have to do is pretty much just drop those parentheses and combine like terms. So positive 1 and negative 7 are like term. So I end up with x squared minus 6, right? Go towards the positives 1 from negative 7. Boom, there's my answer for that one. Okay, and again, that's how we do compositions. You kind of read it backwards and to figure out what to plug in and where. Let's move on. Next, we have inverse functions, and you could see ones where you're asked to find the inverse and to graph them. You might be asked, are these two things inverses? And you can figure out if they are inverses by doing compositions. That was the homework that we had last week, okay, where if you do the composition and you get just x and just x here, that means they are inverses, okay? And sometimes that's easier than actually writing them. But here we're going to actually write the inverse and then graph the function and its inverse on a coordinate grid. And I worked through all 4 of these on the key. So maybe we'll just start with this one because it does already look funky with a fraction. So let's start by just graphing this. Okay, so we'll do it just right below. So to graph this is tricky because it's not actually in slope-intercept form right now. What we should do is send the 5 here and here. So this is actually 4/5 x plus 1/5. Okay, remember, you do have to send that denominator to both because it's underneath everything. Now the slope doesn't make a big difference that it's a fraction, but this kind of sucks. Okay, that means we're going to start up 1/5 of a box. So we're really going to start like right there. And you're just going to eyeball these the best that you can. Okay, so from here, I'm going to go up, and I'm going to let you know I made a mistake twice graphing this on your key, so that's also part of why I'm like, oh, we should do this one. 1, 2, 3, 4. I'm going to go up 4 and forwards 1, 2, 3, 4, 5. So I'm really like right above this 4. I'm at 4 1/5. Then I'm going to go, so I'm at 1/5. I'm going to go down 1, 2, 3, 4, which means I'm at actually 3 4/5. And backwards 5. 1, 2, 3, 4, 5. Boom, right there. Okay, this is hard to do with this tablet, but there's my line that I'm looking at. Okay, I know it's not great. In fact, it's pretty horrible. Maybe I'll try it again. All right, ready? Ooh. Oh my gosh, look at my skills, guys. I'm getting good. All right, sorry to distract. Now we're going to find the inverse, and then we'll graph the inverse function on here. And remember, they should be a reflection of each other over the line y equals x, which this is pretty close to y equals x right now. So to find the inverse function, you flip-flop your x and your y. So normally this is y equals this. So I'm going to change it to x equals, and then I'm going to have 4y plus 1 over 5. So I just changed these 2 locations. Now you might be like, all right, let's send the 5 here and here, and we'll have 2 fractions, and we'll move our 1/5 over. And I kind of agree with you, that would work. But that's actually more work than what you should do. I want you to remember that this sign right here means divide by 5, right? And see how it's underneath everything right now? That means our first step should really be times both sides by 5, right? To cancel out dividing by 5, I would times by 5. So then I'm left with 5 times x, or just 5x, equals 4y plus 1. That's easy. To get my y alone and positive, I'm going to minus 1, and then I'll lastly divide by 4. So minus 1, I get 5x minus 1 equals 4y. Last step is divide by 4. Divide everything over here by 4. And now I'm left with y equals 5/4 x minus 1/4. And again, I sent that denominator to both pieces so that I'm able to graph it. So I'm going to start at negative 1/4, which is pretty darn close to 0, okay? And I'm going to go up 5, so 1, right underneath the 1, 1, 2, 3, 4, 5, and then I'm going to go over 1, 2, 3, 4. Whew. Then I'm going to go down. Remember, I'm at -1/4, so I'm right, I'm right underneath 0. So I'm going to go down 5. 1, 2, 3, 4, 5. And I'm going to go backwards 4. 1, 2, 3, 4, and put my dot. And I'm going to connect those 3 points. Now, you might be saying to yourself, I don't know, Mrs. White, those don't really look like a reflection. Well, remember, they're a reflection over this line right here, y equals x. Okay, so they actually are a nice reflection of each other. And that would be kind of the expectation that you'd be able to do, okay? These are all linear functions. They all have x with a power of 1. I'm not going to ask you to do inverses of anything more complicated than that. Even though we know a square root comes from an x squared, I'm not going to have you do those inverses on your test. Instead, I'm going to focus on you being able to do it with these. Speaking of graphing square root functions, that's going to be the next topic. And then after this is going to be solving radicals. And then those are all the things you could see. So as we're looking at this problem, maybe we should look at the crappiest one possible and do that one. And I'll tell you the crappiest one possible is definitely 36. Okay. So to graph, sorry about that. To graph a square root, we're going to make an XY chart. That's the strategy I gave you, folks. You could use translations, but when we're multiplying by something, it's easiest to do a XY chart. So you cannot just pick any rando x's. You have to use the 3 smallest perfect squares, and they have to equal your radicand. So I'm going to take my inside of my root sign, which is called my radicand, x plus 4, and I'm going to figure out what x value would give me 0, what x value would give me 1, and what x value would give me 4. And the reason why I want 0, 1, and 4 is because these are the 3 smallest perfect squares, which means I'll be able to do it in my head. And I can't do anything smaller than 0 under the root sign because it would be imaginary. So I'm going to -4, -4, and that gives me a -4 for an x. I'm going to -4, -4, and that will give me -3. Then I'm going to -4, -4, and that will give me 0. So these are the 3 x values I'm going to plug into here to get out my coordinate pairs to graph. So now let's do that, okay? I'm going to plug in a -4 here. -4 plus 4 is 0, and the square root of 0 is 0. So right now I have -1/3 times the square root of 0, which is just 0, minus 1. Well, anything times 0 is canceled, so all I'm left with is a -1. So I'm going to go over 1, 2, 3, -4, -1, and put a dot. Now I'm ready to do my next one. I'm going to plug in -3 here. So -3 plus 4 is +1. So right now I have -1/3 times the square root of 1 minus 1. Well, the square root of 1, right, is 1. And 1 times 1, -1/3, is just -1/3 minus 1. Or, those are same sign, add and keep, -1 1/3. Now this is hard to graph, okay? I'm going to go over to -3, I'm going to go down 1, and 1/3 is pretty darn close to that pink one. I get it. And I know that these graphs aren't ideal, but I wanted to give you something on that sheet, okay? You have 6 of these graphs, so that if you wanted to graph them on this, you can. If you want to do it on scrap, it's fine with me, okay? Lastly, I'm going to plug in 0. 0 plus 4 is 4. So I currently have -1/3 times the square root of 4 minus 1. I want to remind you, folks, square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2, okay? Don't think it's 4 because this was 1 and this was 0, right? 2 times 2 equals 4. The square root of 4 is 2. So to do 2 times -1/3, I got to put it over 1. I go across the top and across the bottom. So I'm going to have -2 across the top. 3 times 1 is 3. So I'm going to have -2/3 minus 1. Again, those are same signs. So I'm going to add them and keep that sign. -1 2/3. So this is tricky. I'm going to go over 0. I'm going to go down 1 2/3. It's hard, okay? Now my graph definitely starts here, and it almost looks like a line. It's just very, very flat, okay? And that's my little curve graph here. Now you're like, Mrs. White, it's upside down. Well, yeah, it's upside down because we multiplied by a negative. That's a possibility. It also could look backwards if we were multiplying by a negative on the inside. It's so squished because we're timesing it by 1/3. We did shift it to the left 4 and down 1, but if those translations aren't something you spent a lot of time doing in your respective math class earlier this year, then it's not something I really wanted to focus on now, and that's why I had you make a table. So again, you do not have to do all of these graphs. If graphs is a weakness for you, then I would consider doing the majority of them and double checking them with my key online. Last section is solving, and I did not cross off these numbers 46 and 47 on your sheet, but please cross them off. We did not do ones that had a binomial on the other side, okay? And we're going to just see things that kind of work out like this. So you could have straight up radical equations, which means that you have a root sign. It could be a square root. It could have a 3 here, meaning it's a cube root. You are also going to see rational exponents, right? We've talked about those and how they are equivalent to a radical. And so maybe we'll just do one of each of these. So 52 definitely looks the trickiest, so we'll do 52. But let's also do 49. So I'll bring 49 over here and we'll do 52 below. Both 49 and 52 are going to work out nicely. I want to let you know that one of the remaining problems, either 45, 48, 50, or 51, is going to be a no solution. So make sure once you find your answer, you plug it in and you double check. So let's start off with a little bit easier. Let's start off with 49. We have the square root of 2x plus 3 equals 3. When we're solving this, our first thing we want to do is get our root alone on one side. And once it's alone on one side, we can get rid of it. So here, there's nothing being multiplied on the outside or added or subtracted behind it. It's by itself on the left-hand side of the equal sign. So I'm ready to get rid of this root. Now, if it was a 5th root, which means it would have a 5 here, I'd raise it to the 5th power on both sides. If it was a 3rd root, which means it would have a 3 here, I'd cube it and cube this side. Now, because there's no number here, hopefully you remember this is definitely a square root. So to cancel out my square root, I'm going to square both sides. Cancel, cancel. I end up with 2x plus 3 equals 3 squared, which is 9. So I minus 3, I get 6. I'm going to divide by 2, and I'm going to end up with x equals 3. Now, usually you'd want to stop here, but we know no solutions can potentially exist, so I'm going to plug in a 3 right here. So I'm going to do it in my head. 2 times 3 is 6. 6 plus 3 is 9. Square root of 9, principal root is 3. Perfect. It works great, and I've checked it, okay? No solutions are potentially things with these. You need to check your answer and make sure it does work. So the craziest looking of all these problems is this number 52, because it's got a rational exponent, it's got a 3 here, a -6 here, and stuff going on in this parentheses. So when we see a rational exponent, specifically ones that have a numerator of 1, we're going to look at the denominator, and that's going to become our index number for the root. So this could be rewritten as 3 times the cube root of 3x minus 1. And then on the outside, we're going to have a -6. So this cube root is only applied to the parentheses, okay? And then that equals 0. It equals 0 because that's how they set it up. So now I got to get this root right here all by itself. So I have to get rid of my -6, and I have to get rid of my 3. Now, if this was 3x minus 6, and I had to get my x alone, hopefully you would be like, oh yeah, I got to add 6, add 6. You need to make sure you move things across in the correct order. After I add 6 to both sides, I'm then going to divide by 3 and divide by 3. So I'm going to kind of do that both in the same step right now. So I'll be left with the cube root of 3x minus 1 equals +6 divided by 3, which is +2. Now, this isn't so bad, right? It's a root equals a number. To cancel out a root, I raise it to whatever the index number is here. I raise it to that power. So this is a cube root, so I'm going to cube it. And what I do to one side, I have to do to the other. Cancel, cancel. 3x minus 1 equals 2, it's not going to be 6, it's 2 times 2 times 2, which is 8. Now I add 1, I end up with 3x equals 9, divide 3, and I get x equals 3. X equals 3. So I should double check and plug it in. I actually like it when it's in its radical form more, so I'm going to plug it in here, 3. So 3 times 3 is 9. 9 minus 1 is 8. So I currently have 3 times the cube root of 8 minus 6. Now, hopefully you recognize 8 is a perfect cube. It's 2 times 2 times 2, right? We actually did that work right here. So I know this is the same thing as just 2. So I technically have 3 times 2 minus 6. And 3 times 2 is 6. Minus 6 more is 0, which is what we should have ended up with. So that one, I checked it. It does work. Okay. Again, of the 4 that are left, 45, 48, 50, and 51, one of those is going to be a no solution. Please take your time and make sure you plug it in and check. So these are all of the items that you could potentially be seeing on your test. There will be no, really trying to mess with you problems. I also want to point out that there are no word problems, so you don't have to worry about word problems on there either. I want you to try your best and let your parent know to pop me an email when you're ready, keeping in mind that this test is going to be due on the 13th. Tomorrow, I'm going to release an assignment that says Chapter 5 test. That way, if you decide to do it early, you can hand it in to the Google Classroom. It is not, okay, it does not mean that you have to do your test on Friday, okay? But I know I'm going to have a couple people who are probably going to study and don't want to wait till Monday to take it. If you take it early, then you literally have the beginning of next week off, right? You don't have to look for anything until I release it next Wednesday. Okay, your official test day is on Monday, so you should have a parent pop me an email Sunday night or Monday, so you can take it Monday or Tuesday and get it into me by Wednesday. Okay, so I am going to allow you to turn it in on Wednesday if you need to. Okay, so reach out if you also need to. I am going to have office hours tomorrow from 1 to 2. If you have any questions, pop me an email. Thank you, folks. Bye.